In our previous lecture, we discussed hash. We looked at a real-world example of how an MD5 generator produces a hash digest. Hashes serve as the rudimentary building block to many different integrity controls. One particular integrity control that utilizes hashing as a building block is a digital signature. Digital signatures are one of the most advanced and secure types of electronic signatures. You can use them to comply with the most demanding legal and regulatory requirements because they provide the highest level of assurance about each signer's identity and the authenticity of the documents they sign. Digital signatures use a certificate-based digital ID used by an accredited certificate authority or trust service provider, so when you digitally sign a document, your identity is uniquely linked to you. The signature is bound to the document with encryption, and everything can be verified using underlying technology known as public key infrastructure, or PKI. One way that digital signatures serve as an integrity control mechanism is that they help us achieve the goal of non-repudiation. Non-repudiation in network security is the ability to prevent a denial in an electronic message or transaction. The aim of non-repudiation is to ensure that an individual or organization is unable to deny at a later date that they were the originator of that message or transfer. So how is a digital signature created? To begin, the person signing the document uses a hash function to create a digest of that document. The hash generated is encrypted using his or her private encryption key. The recipient of a digitally signed message can then use the sender's public key to decrypt the signature and then compute the hash value of the message themselves and compare the values from steps 1 and steps 2. If they match, the message is authentic. Let's discuss digital certificates. Digital signatures can be used to create digital certificates. A digital certificate is like an electronic passport for exchanging secure information over the internet using the public key infrastructure, otherwise known as PKI. They are used to transmit public keys securely.